let's say I gave you this. Formic acid, Ka formic acid is 1.8 times 10 to the negative fourth, and it has a formula of HCOOH. Okay? Hydrocyanic acid has a Ka value of 4.9 times 10 to the negative ninth. Okay? So there's, from this, you should be able to dream a whole bunch of different things. Which of those two, formic acid or hydrocyanic acid, is the weaker of the two acids?
Hydrocyanic.
Why?
Lower Ka.
Okay. So you're saying this is going to be the weaker of the two.
I am.
Yeah. Why?
Small K.
What does that mean? Just
Yeah,
saying
ionized
it's a
is
smaller
like-
Ka
ionized is
doesn't
like- ionized
mean
equilibrium lies on the
Bigger
left.
KB.
Okay. How do you calculate Ka? Hydronium ion concentration, anion concentration divided by HA, right?
A lot of HA.
A lot of HA. So, mathematically, what's the only way you can produce a small Ka value?
Big HA, small H plus, small H minus.
Okay? So, if this is going to be 10 to the negative ninth, that means that these hydronium ions and these anions concentrations are really small. Okay? So when both of these try and ionize, they will ionize to a certain extent, but this is going to ionize much, 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 much less. Because when I multiply these numbers together, I'm going to get a much smaller value. Natalie, which one is going to have the stronger conjugate base? Formic acid with the COOH, so which one will be the stronger base? COOH or CN? Which will be the stronger base?
CN.
Yes. Why?
Because
Hey, don't worry, it's on the study guide.
Gosh.
it's Ka
It's a
value.
friendly bribery.
Because its Ka value is lower, which means it's more likely to ionize.
Other way.
Other way.
It's less.
Less likely to ionize. As the acid. So, here's the story. Okay, here's the flip side of this. These cyanide ions really, 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 really want to hook up with hydronium ions. And they really, really, really want to remake the acid. Okay, what to say? That's not hard. So this really wants to make HCN, right? This wants to make some formic acid, but not quite as strong because this has such a small Ka value. So if you were to do a titration, okay, with a pH curve, and one of the pH curves would look like this, and there's like a pH of 7, and the other one would go something like this, and there's that equivalence point. Which one of those two, the purple line or the black line, which one of those would be the titration of the hydrocyanic acid, and why?
Purple.
Purple. Why?
Weaker acid, bigger and stronger.
Bigger.
What did you say, Jonathan?
It's a weaker acid, so it starts at a higher pH.
Okay, that's part of it. Even if you just looked at the beginning, okay, assuming that they both have the same molarity, okay, you have the same molarity, 0.1, whatever that number is.
It's equally.
Remember that the higher the pH is, the lower the concentration of your hydronium ion. There's an inverse relationship there. So with this being a higher pH, that means that there's a lower hydronium ion concentration. Now, again, listen to me. Just because you have an acid like HCl, does that mean that there is a high concentration of hydronium ions? Absolutely no. Because here's the deal. remember, when you're talking about pH, and it's tough to overstress this, that's, whoa, the negative log of your hydronium ion concentration. It is not the negative log of the acid, okay? So just because this has hydronium ions doesn't mean that there's a bunch of hydronium ions floating around, okay? It is an acid. There are hydronium ions. Is this a Bronsted-Lowry or Arrhenius acid?
It has an H.
It has an H. Therefore, it is
Arrhenius.
Arrhenius. Okay. Could also be Bronsted-Lowry, but certainly because it has an H.
That makes them both.
Yeah. So here's the story. Just because there's an H doesn't mean that there's a lot of hydronium ions. Okay. Matter of fact, there's going to be very, very few hydronium ions at all. They're there, but they're bound up. Okay, they're not free to mingle because they're hooked up with the base. So let's talk about the equivalence point. Why are both equivalence points above 7? No one from this side of the room can answer.
What about me?
What did I just say? No one from this side of the room can answer. Okay? You're on that side of the room.
Segregation. Segregation today, segregation tomorrow, segregation today. George Wallace. 1863. We don't want to integrate. Golly, man.
Go back in the game, bro. It's not brotherhood. I'm sorry. It's time.
Who in this room has lived in Africa for 2.5 years?
Wait a minute.
Okay. So, anyone besides the left side of the room?
Michael.
Olivia Pruitt.
Well, inverse. I think Jordan Robinson.
No.
Why is the pH?
Why
Or
are
they
both
both
pHs above 7 at the equivalence point?
I don't know.
It takes a lot more.
No.
They're not strong acid.
No.
It takes more.
What's the only way?
I forgot. Wait, what was the question again?
Oh, God. Hey, all of
That is the right side of the room.
Do not fall on the right side of the room.
No, they're the right side. They're the right people.
Michael, take this one.
Michael's on the
What's
down the
the
middle.
Big Mike?
Yeah, Michael.
Weak acid.
Big Mike safety.
Final answer, weak acid.
Holy fuck.
That's the lamest answer that you could possibly.
Hey, am I wrong though? Am I wrong?
No. But that's like
I
you
have a
could have
question.
said the sky is blue.
Okay, well that's not.
Okay, that's
not
a true
right.
statement, but it doesn't answer your question.
Well, if
I have a
it's
question.
Yes.
Are this might be really dumb that I'm asking this right now, but are all weak acids equivalence points above 7?
Yeah.
Oh my god.
Gram concentration starts out way higher
Why?
because their pH is way lower. I don't know. Because they're
It's higher.
Or, I mean,
No, she didn't. She's talking about. She just said.
God, I question my life choices at this
That is
point.
way better than Michael's.
What's the only way that you can have a pH above 7?
weak acid.
What do you have to have a lot of?
Oh.
OHs. Okay, that's it.
What's the
You have to have a lot of OHs. That's it. Okay? If your hydroxide ion concentration is the same as your hydronium ion concentration, what's your pH? 7. It's neutral, right? So the only way that I can have a pH above 7 is if I generate hydroxide ions. So at the equivalence point, here's the whole key to this. You have, say, for example, hydrocyanic acid. And you're going to neutralize that with OH. What are you going to get out of it?
Water.
Water and
H.
CN, right?
Yeah.
Let's say you have 0.1 moles of your acid. How many moles of the hydroxide are you going to need to neutralize it?
0.1.
1. Oh.
Oh dear.
That's 0. How much of that's going to get used up?
All of these.
All of it. Lord, we've not talked about this concept before. How rude of me to introduce it the day before the test. What? So, what's going to happen over here?
We do another one.
It's gonna be
Oh!
Secondary
a
reaction.
second moisture.
Another
Now I'm going to create a secondary reaction. Now, if this had been hydrochloric acid,
No way was it.
they're there. Is it going to react with the water?
No.
Because it's stable.
Yeah.
Okay? So, again, if you hand in this test on Monday and you have not done a secondary reaction between an anion and the water to recreate the acid and the hydroxides, you have done something horribly wrong. Okay? Isaac Bruce, what are you going to set up to work a problem like this? Yes!
That's textbook.
You're going to set up a rice chart. Is this
What?
Is this a neutralization reaction?
The second one?
Yes.
No,
No. Why?
because there's no acid.
You're making an acid.
Well, but you're not neutralizing acid.
You're not neutralizing it.
Oh.
There's no stoichiometry involved. This thing just wants to reach its own equilibrium. So are you going to use molarity?
You are okay.
You're going to use molarity. Because it's not a neutralization reaction. So if there's 0.1 moles, I need molarity. What am I going to divide it by? Total volume in liters. So let's say this becomes 0.05, just to make up a number. What's the initial concentration of my acid and my hydroxide?
A donut.
Oh,
Goose egg.
Goose egg.
A donut has a second one.
this is going to ionize X. 0.05 X. Cool. Now, am I going to use the Ka value or the Kb value?
KB.
Kb. Why?
It's
Going to Kb or not to Kb?
That is the question.
That is the question. In this case, I choose to
KB.
because what's the cyanide acting as?
Base.
How are you going to find the Kb value?
Oh, KB. 1 times 10 negative 14.
So 1.0 times 10 to the negative 14th, which is not water.
It's what?
Autoionization constant, if you really want to go is going to equal your Kb value. Now, what's your Kb value going to equal?
A number.
Products are reacted.
How about x squared
Oh, yeah. Oh, you're right.
over 0.05?
Hold up.
Now, when you get x,
Hydroxide.
Yep.
you're going to get your hydroxide ion concentration.
14.
POH.
Take the negative log of x. That's going to get you your
14 minus.
POH. 14 minus your POH is going to get you your pH. Okay? Which shifts the pH above 7. Okay? And the stronger that base is, the bigger the value of x is, the farther it's going to shift it above the equilibrium point.
How many writing questions are on the test? Like right or right? 4.
Not that many.
John,
John,
is there going to be a question where you have to say what kind of like reaction it is? Like the 2 different types of acid reactions? Like Bronson Dory or the other ones?
you just have to know the general definition.
John, are you
Right.
aware you just pronounced it wrong?
Yes.
All right. Now, let's go back to the formic acid. Okay? And I'm going to react with hydroxide, and you're going to get water and the. What would I have? First of all, could I make this a buffered solution?
You have to make the salt one.
So what two conditions are necessary to have a buffered solution? Weak acid and salt. So I could add sodium formate to this, right? Okay. So by adding the anion, what does that do in terms of equilibrium?
Helps mitigate the pH change.
Why?
I just remember that definition.
Wait, are you talking about? Oh,
Where's
okay.
the thing all the time?
Because Ka has to stay the same. So you got this. So you have more anions.
Okay. You have two things in that solution. You have the weak acid and you have the conjugate base off of the weak acid. If I add hydroxide to it, what's the hydroxide going to react with?
The weak acid.
The weak acid, which is this reaction up here. If I add a strong acid to it, like hydrochloric acid, what are the hydronium ions going to react with? The anion. The anion are going to make more acid. Make sure that you can understand both of those. We're good. So let me hint you guys, I know you South people better go. So here's what you've got. Yes, there is a review, Natalie.
Thank you.
Breaking.
So this isn't the test, but it's a lot of the test. Now, anything that we have covered up to this point is fair game. Like on that even going back to that first review where you find like empirical and molecular formulas, stoichiometry problems, like there might be like a limiting reactor problem. Basically, anything that we have done is fair game. This is just primarily the acid base and KSP stuff. So, again, you're going to have a blank copy of this. You're going to have the answer key to it. If it were me, I would take this and I would treat it as the test. I wouldn't even look at my answer key. I would just treat this as the test and I would be working. Then I'd go back and look and see how I did on it. Okay? That's what I would do if it were me. So, all right, shut down yonder camera, please. I'll post this